All right, so this is actually applications of trig. So it's you need to use a calculator when you do this assignment, and I think it's the third assignment of week 2. Okay, so there are calculators here. You just have to ask Miss Geyer, and she will give you a calculator. Okay, or Miss Elliott, she knows where the calculators are. And if you ever go over to Gateway, excuse me, you will ask Miss Schneider, okay? Just, huh? Oh, okay. Okay. Anyway, so that's if you need those, and if you have your own calculator, definitely bring it. But if you have a calculator, let me just show you. It should look something like this, okay? Do you guys see that?
Yep.
Okay. No, don't fib to me. You really have to be telling me the truth here. All right. Anyway, it has to look like something like this. A TI-83, a TI-84. There's other ones that are higher, but you really don't need anything higher. Okay, so trig applications, these are like real life examples, right? So let's get started. So the other thing that is talked about in this third assignment are angles of elevation and angles of depression. Angles of elevation are the angle made with the horizon. So if you are here and you're looking up, the angle from the horizon to whatever object you're looking at is the angle of elevation. Does that make sense? Okay, and if you are up high and looking down, okay, that was going to be the angle of depression. Make sense? Davina, does that make sense to you? All right, so let's get started. We have about 6 problems. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We only have 5. Okay, so the problem here, we have a closed circuit television camera, and it's mounted on a wall that's 7.4 feet above the security desk. And it is used to view an entrance door 9.3 feet away from the desk. We want to find the angle of depression for the camera lens to the door, where the door is, okay? So it's pretty typical of something that you would see like in any kind of stores anymore. They have those security cameras. So here's the picture. There's the camera, there's the desk, and it's 7.4 feet above, and here's the door, all right? And the other thing that we know that it is 9.3 feet away from the desk and the camera, okay? So what we want to find is that angle of depression. Make sense? Because here is the horizontal and we're looking down. All right? So, and from geometry, you should know these 2 lines are parallel. This line cuts those 2 lines, so these are called opposite interior angles, and they are the same. So, anybody have any idea what either sine, cosine, or tangent, what we're going to use to try to solve this? Do you remember what sine, cosine, and tangent are in relation to a triangle, right? Okay, so what is sine? Davina, type it in there if you know. And you guys tell me if you know.
I think it's opposite over hypotenuse. Yep.
Very good. It is. It is. I don't know if you heard that, Davina, but the 2 people that are here said opposite over hypotenuse. Very good. So would we use that? Do we know the hypotenuse? Do we know the opposite side? And again, think about this. This is the angle that we're trying to find, or this one. Do we know that opposite and the hypotenuse? Remember that SOHCAHTOA only works with right triangles. So do we have enough information to use sine? No. Okay, what about cosine?
Tangent.
Tangent, right. And what is tangent?
Opposite over adjacent.
Opposite over adjacent. Good. And we know that because we have the opposite, we have the adjacent. So, now, do I have the angle? Remember, if I put this into this calculator, it's going to ask me what the angle is, but I don't know that, right? So when you're using a calculator like this, what we do know is we know what that tangent is equal to, correct? It's equal to 7.4 divided by 9.3. So what we're going to do is we're going to hit second and then tangent, and that gives us this tangent inverse. Now we can put in our numbers. And what it gives us, well, this is not set. Oh, do you see, does that make sense? Does it make sense that that angle is 0.6? Think about it, does it? I can't see. Davina, if you're talking, I can't see. Doesn't make sense. So what you have to do, this is, and I should have said this first, go to your mode, and you see down here where it says radian, you want this in degrees, okay? So you would go down here, go over to degree, and then hit enter. Make sense? Now let's try it again. Okay, so it's clear. No. So let's just, all right guys, do me a favor. Try not to mess with that, with your cursors or anything. Okay, so we've got it here again. There, that makes much more sense, doesn't it? That it's 38.5 degrees. Okay? Make sense? Easy stuff, right? So let's do the next one. All right, so we have the world's longest escalator is in Leningrad, underground in Leningrad Square. The escalator, it has an angle of elevation of 10.36 and a rise, vertical rise of 195.8 feet. What is the length of the elevator? So here's our picture. Escalator, I keep saying elevator, don't I? There's our angle, right? So what are we going to find? We want to find the length of the escalator. Which part of this, well, no, which part of this picture is that going to be? Is it going to be the opposite and looking at where our angle is? Okay, is it going to be the opposite? Is it going to be adjacent? Or is it going to be the hypotenuse? Hypotenuse. So what do we want to use? Sine, cosine, or tangent? Cosine, remember it's CAH, right? Do we have the adjacent side? Look at the picture. Do we know this? It'd be sine because we know the opposite. What we want to find is the adjacent. All right, so to set that up, it's going to be sine of 10.6 is equal to 195.8 divided by the hypotenuse, right? So I'm going to put that in. So putting it into my calculator, it's going to be, and you guys can write this out and figure this out. This part is not going to be that hard for you to figure out this that I just wrote in here. Okay? Does that make sense? Okay, ready? Enter. So the length of this is 1,088 feet. Okay, make sense? Okay, and it kind of does because the angle isn't very high, but it's going up. You know, if you just think about the way that it's going to look, that's a long way to go. All right, let's go to the next one. Basically, what I'm trying for you guys to think about is making sure that you know which are you going to use sine, cosine, or tangent, and then when you look at your problem, are you going to use just the regular sign, or are you going to use that inverse? Okay? All right, so we have the height of a flagpole. We want to find how tall a flagpole is. If it casts the shadow, so here's our shadow, of 9.32, when the sun makes an angle of 63 degrees to the horizontal. So this is 63 degrees. Again, remember those opposite interior angles from geometry. So this and this is going to be the same. We know this. What we want to find is this. What are we going to use? Sine, cosine, or tangent? Think about your SOHCAHTOA. What are we going to use? Sine, cosine, or tangent? We do need the opposite, but do we know the hypotenuse? No. So we can't use sine. What does cosine stand for? Good. Okay, so we have the adjacent, but we don't have the hypotenuse, so we can't use that. It's tangent because that is opposite over adjacent, and what we want to know is that opposite, how tall that is. Okay, so let me see. Let's get up our calculator again. So what we have is tangent, and since we know the angle, we're not going to use the inverse. The only time you use the inverse part of it is when you want to find the angle. Make sense? Yeah. Okay, thank you. So we have tangent of 63 degrees, right? And then times 9.32. So the height of this is 18.29 feet or 18.3 feet. Make sense how we're doing it? All right. I think we just have two more. Okay, so a train must climb at a constant gradient of 5.5 meters for every 200 meters of track. We want to find the angle. Okay, so since we want to find the angle, are we going to use tangent, cosine, or sine? And is it going to be the inverse? Or is it going to be just the regular? Okay, first off, let me back up and ask one question at a time. Okay, is it going to be the regular sine, cosine, or tangent, or is it going to be the inverse? We're going to use the inverse. Why?
Because it's an angle, we're not trying to find the sides, we're trying to find the angle.
Perfect, because we're trying to find the angle. That's excellent. Okay, so we know we're going to use the inverse. Now, are we going to use sine, cosine, or tangent? Okay, so cosine means you have to have what sides?
Over hypotenuse.
Cosine, something over hypotenuse, but is it opposite?
Oh,
It's
it's
adjacent.
So
So we want the sine. All right, so we want inverse sine, right? Because you've already told me that. All right, so remember, if you want the inverse, you have to hit second and then the sine, right? And then we put in our numbers. Remember, it's opposite divided by hypotenuse. So the angle, it's a really shallow angle, right? Because it's so long. That piece of track is so long. Make sense?
Yeah.
Okay, last one. All right. So we want to find theta so that we can figure out the pitch of this roof. So construction is like the main kind of place that you're going to use all kinds of trig and all kinds of geometry. Algebra a little bit just because you have to know how to manipulate the problems that you're doing, but mostly it's geometry and trig, all right? So anybody that says they want to be a construction worker, yay, good for you. However, you've got to have some math knowledge, okay? So what we want to know is, what is this angle theta? How can we find that angle theta? This is not a right triangle, is it?
Right.
How can we make it into a right triangle? Exactly, we're going to split that down the middle. So what does that make this part right here? So what we're going to do, Ryan knows how great my drawing is. Okay, it's almost straight. Okay, so that's what we're going to do, right? Oh, it's gone. Wait, I want it back. Okay. Hi, James. How are you? Okay, so that's what we want, right? We're going to split it in half. So what is this length then? We've split this thing in half. What's that length? 15 divided by 2 plus 0.6. Do you see that? Because the 15 is only this part, like the house, the width of the house. Make sense? So it's 7.5, because that's 15 divided by 2, plus 0.6. So what is 7.5 plus 0.6? Close. It's 8.1. Okay? 8.1. So 7.11 is not terrible because you just forgot to carry the 1. All right, so it's going to be 8.1. So we know then that this, okay, I'm going to try and write. Wait, I got to do this. Okay. Forgot my pen. I thought about that today too. Okay. So what am I going to use? First off, am I going to use sine, cosine, tangent, or the inverse of them? Am I going to use the sine, cosine, or tangent, or the inverse? Going to use the inverse, right? Okay. And am I going to use sine, cosine, or tangent? Look at which one do you think? Serenity said cosine. Okay, cosine, because we know the adjacent and the hypotenuse. Alrighty, so let's do that. So, and we're going to use the inverse, right? And it's going to be, what do I put my numbers? How do I put my numbers? What goes on the top? 8.1 goes on top. And then 8.3 goes on the bottom. And so that's my angles. That's going to be the pitch of the roof, 12.6 degrees. Okay? So that's how you're going to use today, or whenever you get into this assignment. This is the third assignment of the second week. That's how you're going to use, so we're not going to, these things. I thought I put questions here. There we go. There's my questions. So that's how you're going to use those things, okay? So, does anybody have any questions? All right, you guys, there is like a little place in week 2 that says webinar and discussion. All you have to do is go in there and put attended. You don't have to answer any questions, okay? And same for Davina, although she didn't really participate, we'll say yes. And James, I think you'll be okay too. Just put in attended. For the rest of you guys, what I want you to tell me is, if you do not know the angle, do you use the regular cosine sine tangent or the inverse sine tangent? All right, so just that's your question, and I will write it in the discussion part. So for the rest of you, thanks for coming, so I don't have to talk to myself. All right, guys.